Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at multiplying polynomials. Specifically, we're going to take a look at multiplying a monomial by a monomial and a monomial by a polynomial. Now, to start us off, let's think of an area. So we can think of multiplying two numbers as actually finding the area of a rectangle. So for example, let's say we are multiplying 2 times 3. So on the left side here, we have 2. On the top, we have the length of 3. So we can think of this as splitting this rectangle up. We have 2 units on the left and 3 units on the top. So when we count the little individual rectangles inside, we can see that we have 6. So 2 times 3 is equal to 6. So we can apply this analogy to multiplying numbers to also multiplying monomials. I'm going to show you first how to multiply monomials using Algebra Tiles. So here we have a picture of 2 times 3x. So on the left side I have 2 units. On the top I have 3 x's. So I can actually draw this out as one big rectangle. When I multiply them together, I will have an area that fills up this space that I've drawn here as a big rectangle. So the 1 unit gives me another one, and the next one, and then our third one. And then the same with the next unit. When we have the next unit multiplied by an x, we have another one filled in, and another one. Now all of these are positive, so I'm actually going to shade them all. And if you don't want to shade them, you can also just put in a plus sign so that we know they are positive. So our solution is what the area is that I've shaded. And we can see that there are now 6 x's. All right, let's take a look at how to multiply 2x by 3x. So on the left side here, I have 2 x tiles that are stacked on top, and then I have 3 x's that are laying sideways. So when I multiply this, I'm going to have this area here, which is going to be filled out. And using these algebra tiles as my lines, I can use this as my guide here, that I will cut across here like this, and then I will cut across going down like so. So each one of these, you can see, is a square, and this square tile is an x squared tile, and these are all positive. So we have 6 of these x squared tiles. So 2x times 3x is equal to 6 x squared tiles. So when we multiply monomials, we can see that we actually multiply the numerical factors, or we think of these as the numerical coefficients. And then we multiply the variable factors, the x times the x. Now remember to use your exponent rules. Remember that when we multiply x times x, we're going to add the exponent, and each of these exponents are 1, and that's why we have now x squared. Let's take a look at some examples which do not involve algebra tiles. So let's multiply these ones together here. So like I've said before, we'll multiply our numerical factors, or the coefficients. So we have 2 and 6, which we multiply to get 12. And then we have x to the 5 times x to the 4. So that's going to be x to the power of 9, because we're going to add our exponents 5 plus 4 to give us 9. So the next one we have is 7 times 3. So we're multiplying our coefficients. So that gives us 21. And then we have m to the 9 times n squared. Now those are not like terms, or they don't have the same base, so we can't actually join them together. So we're going to just write this as m to the 9 times n squared. So when we have variables that are not the same, we actually don't do anything with them, but we actually just place them multiplied beside our coefficient. All right, let's take a look at this last one where we have 3 monomials. So same as before, we multiply all of our coefficients together. So we have negative 2 times 4 times 7, which is negative 56. And then we have x squared, x cubed, and x to the 8. So we're going to add up all of these exponents. So we have 2 plus 3 plus 8. So that will be x to the power of 13. And then we also have this lone y at the very end here. And it doesn't match up with any of them, so we are just going to place y at the very end. So that's how you can multiply monomials. All right, next we're going to take a look at how to multiply monomials with polynomials. Now, before we do that, let's look at multiplying numbers first, using an area model again. So here we have 7 times 98, so we can use this area model to multiply large numbers, such as this. So we're going to place 7 on our left side. And instead of just placing 98 all across here, which is a little bit more difficult, let's cut this long rectangle up into 90 and then 8. So this length is 90, the smaller length is 8, but the entire length is 90 plus 8, which gives us 98. Now the purpose that we've done this is so that we can actually multiply these very easily now. So inside this longer rectangle in the first piece, we have 7 times 90, and we know how to do that because 7 times 9 is 63. And then we're going to add a 0 because we have 9t, which has a 0 in it there. And then the smaller rectangle, we have 7 times 8, which equals 56. So 630 represents the area of the first long one, 56 is a little piece. So to find the area of the entire rectangle, we add the two pieces together, and then we get 686. So when we multiply a monomial and a polynomial, we're going to do something similar. We're going to use something called the distributive property. And that is to remove the parentheses or the brackets. Let's take a look at this with Algebra Tiles first. So here I have negative 2 times 3x minus 1. So on the left side here I have my negative 2. On the top I have 3 x's and a little negative 1 square to represent the minus 1. So when I multiply this all out, I know that I will get this big rectangle like so that has to fill it all up. And then using the 1s as my guide, I know that here I'm going to cut this in half this way. And then using my Algebra Tiles this way, I'm going to cut it going down. So this would cut here, here, and then over here. So now the only thing we need to worry about is actually this time is whether they are negative or positive. So here we can see that we have a negative 1 multiplying by a positive x. So this will be negative because a negative times a positive is negative. So all of these in here will actually be negative. And now we're going to take a look at the 1s, and we can see that we have a negative 1 over here times a negative 1 over here, which gives us here, that means that this has to be positive, same as the one below. So that means that my answer here now, I have 6 x's, but they're all negative, so that's negative 6x. And then I have plus 2 for the 2 positives at the end. Let's take a look at one more. So we're going to draw this rectangle out. And this represents negative 2x's on the side, and then 3x minus 1 on the top, just like before. So this time, however, we have 2 variables on the left. So we're going to draw our rectangle, and then we're going to cut it out using our Algebra Tiles, like so. So draw it cutting down, and then over here as well. So we can see that the shapes of these 6 big squares are actually x squareds, and this is a negative x tile times a positive x tile. So we know that these big x squareds are actually going to be negative. So let's place this in the middle. So all of these will be negative. And then we have a negative x tile times a negative 1, which means that this long stick here at the end are both positive. So now we have negative 6 x squareds, and then we also have 2 positive x's at the end, because we have 2 positive x sticks. Now looking at the equation, we can see that what we're going to do is we're taking the negative 2, which is those 2 units on the side, and we're first multiplying it by these 3 x tiles. So we're taking negative 2 and we're multiplying it by 3x, and that gives us this negative 6x. And then we're taking these same negative 2's and then we're multiplying it by that last unit at the end, so we get plus 2, which is taking negative 2, multiplying it by negative 1 to give us positive 2. In the second example, we have our negative 2x's over here, and we're multiplying it by our positive 3x's, and that's how we get these negative 6x squared. So algebraically, that's negative 2x, and we're multiplying it or distributing it with 3x. Then we're taking the same negative 2x, and then we're multiplying with the negative 1 at the end, and that's what gives us our positive 2x. So we're taking the negative 2x algebraically, multiplying it with negative 1 at the end, and that's how we get plus 2x. Let's do some questions without algebra tiles. So here we have 7y, and we're going to multiply by everything inside these brackets. So 7y times y is equal to 7 times y squared. And then we're going to take 7y times negative 5. And that's negative 35y. In the second one, we're going to take negative 6x times 3x squared. So that's going to be negative 18. And then x times x squared, we're going to add our exponents, and that's going to be 3, because we have x to the 1 times x to the 2. Next, we're going to multiply negative 6x times negative 8x. So negative 6 times negative 8 is positive 48. And then we have x times x, which is x squared. And then finally, we have negative 6x times our positive 1, which gives us negative 6x. All right, let's take a look at one more. So 5x squared, distribute it with the first term, so times negative 2x squared. 5 times negative 2 is negative 10. And then we have x squared times x squared, so that's x to the 4. We add our exponents, 2 plus 2. And then we have 5x squared times positive 9x, so that's going to be plus 45x. And we have x squared times x to the 1. So 2 plus 1, our exponent is going to be 3. And then finally we have 5x squared times negative 4. 5 times negative 4 is negative 20. No x's with the 4, so we just put our x squared from our 5x squared. So that is how you distribute and multiply a monomial with a polynomial.